kinematics in one dimension. We will be covering distance, time, and speed, and then talk about displacement, velocity, and acceleration. Distance, time, and speed. Kinematics is the study of objects in motion. Motion is described in terms of distance, time, and speed. Now these first three only have a magnitude, they only have a size associated with them. Then we have displacement, velocity, and acceleration. They certainly have a magnitude or a size, and they also have a direction. Scalars are quantities that only have a magnitude, which is a number or a value. They do not have a direction. And those examples are time, distance, and speed. Then we have vectors. Those are quantities that have both a magnitude and a direction. So those are displacement, velocity, and acceleration. We'll be using the meter as our standard for measuring distance. The symbol for distance is D, right? D for distance. And the symbol for the meter is M, M for meter. So here's half of a meter stick, and the distance from here to here is 20 centimeters or 0.2 meters. We'll be using the second as our standard for measuring time. The symbol for time is lowercase t. The symbol for second is s. So the distance here is 10 seconds on the face of the clock there. And you can click here for a nice video on measuring time and distance. Speed is defined as the distance traveled divided by the time it took to travel that distance. Or, just using their letters, S is equal to d over t. Speed is not a fundamental aspect of nature, but it is the ratio of two things, distance and time, that are. The units of speed can be seen by substituting the units for distance and time into the equation. So we have speed is distance over time, distance measured in meters, time measured in seconds, which is abbreviated as m over s, and we read that as meters per second. Let's work a problem. We have a car traveling at constant speed, and it covers 65 meters in 5.0 seconds. What is its speed? Answer on the next slide. So here's our givens. Distance is 65 meters, time is 5.0 seconds, and we're looking for speed. So don't get confused between seconds and speed there. You have to take it into context. So speed, distance over time. Here's the distance. Here's the time. Carry out the math, and we get the speed is 13 meters per second. Second example, we have a car moving at a constant speed of 21 meters per second. What distance will it travel in 4.0 seconds? So try working it out yourself before you go to the answer on the next slide. So here we go. We list what we're given. Speed is 21 meters per second. Time is 4.0 seconds. We want to find the distance. We start with our equation, s is equal to d over t, and we try to solve for the variable first by algebraically isolating it. So we multiply both sides by t, we get this. Then we switch the equation around, totally legal, right? If st equals d, then d equals st. Substitute in our values for speed and time, and we get 84 meters.